everyone, we're going to determine the convergence or divergence of the series and identify the test or test. We have n factorial times e to the power of negative n. So let's use the ratio test, and we can also use the nth term test. So I'll do both. Let's look at the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. So that's going to give you the limit as n approaches infinity of n plus 1 factorial times e to the power of negative n plus 1. All right, divided by a sub n, which is just n factorial, divided by e to the power of negative n. Now let's simplify this a little bit. We get the limit as n approaches infinity. This part right here, remember, for the n plus 1 times n factorial divided by n factorial. So that's going to give you just n plus 1. And for the e's, this is e to the power of negative n minus 1. And then if I want to move this up in the numerator, this is going to be e to the power of n. So what happens is you can put this together with your product rule for exponents. And you're going to get, this is times e to the power of negative 1. And it looks a little better if you write it as the limit. It's n approaches infinity of n plus 1 divided by e. Now, as what's going to happen, e, you recall, is a constant, 2.718. So as you put a large number in, this is going to go off to infinity. So it's greater than 1. Therefore, it's divergent. Also, we could just use the nth term test and just take the limit of the whole thing. And this would have been the limit of n factorial divided by e to the power of n. And it's not 0. It doesn't equal 0. In fact, this is going to grow a lot larger than the denominator. Since it's not equal to 0, then it's divergent. Thank you. Have a nice day. Bye-bye.